Hey everyone, so these are the video solutions for Worksheet 5.3. We're going to be talking about mostly radical functions and functions that involve rational exponents in this case. So for number one, we've got to solve the equation x plus 1 is equal to the square root of 3x plus 7. So in general, with equations that involve radicals, when possible, we're going to want to isolate the radical. So that means that we want to get the square root, the cube root, whatever, on one side, and then any other loose terms onto the other. Sometimes we can't do that, but if you can, you want to do that first. In this case, it's already been done for us. So we've got a radical on one side, and then we've got all the other loose terms on the other. So now we can go ahead and proceed to get rid of the square root. And the easiest way to do that is going to be to go ahead and do the inverse of both sides. Essentially, we're going to square both sides of this equation. So let's go ahead and do that first. So we're going to take x plus 1, we're going to square that, and then we're going to take the square root of 3x plus 7 and then square this. So this is the mechanics that we apply to solve for x. Now, one thing that we're going to notice here is that by doing this, by squaring both sides of the equation, we're going to leave ourselves open for the possibility of a false solution somewhere along the way. So we're going to keep that in mind when we get to the end of this solution here. Okay, so on the left side, we're going to go ahead and multiply out x plus 1 squared, and that's going to give us x squared plus 2x plus 1. And if we square the square root of 3x plus 7, we'll just get back 3x plus 7. So in this case, we've just got a quadratic equation to solve this. So let's go ahead and we're going to set it equal to 0 and then solve for x. So I'm going to subtract 3x from both sides, subtract 7 from both sides, and that's going to give me x squared minus x minus 6 is equal to 0. Quadratic, we could use a quadratic formula if we want to, or we could see if there's factors. In this particular case, this will factor pretty nicely for us as x minus 3 times x plus 2. And since this product is equal to 0, we can use the zero product property to say that this means that either x minus 3 has to be equal to 0 or x plus 2 has to be equal to 0. With these two equations, we get the possible solutions that x could be 3 or that x could be equal to negative 2. Now, what we are definitely going to want to do here is check these. So let's check these solutions. You always want to do this when you've got a square root equation where you have to square both sides, and we're going to see specifically why in this case. So let's go ahead and check these. So we'll start off by checking the x is equal to 3. So we're going to take x equals 3 and we're going to substitute it back into the original equation. So we're going to put in 3 plus 1. Let me clean that up a little bit. So we'll have 3 plus 1 is equal to the square root of 3 times 3 plus 7. And we want to figure out if this is true. So I'm going to put a little question mark above that equal sign because we don't know this is true just yet. So if we add 3 plus 1, we're going to get 4. And we're checking to see if that's going to be equal to the square root of 9 plus 7 or 4 equal to the square root of 16. So is this the case? Well, we know the square root of 16 is just positive 4. So 4 equals 4. We can check this. So this is definitely going to be an accepted solution, x equals 3. Okay, so let's try the other one. So the other one that we had was x equals negative 2. Now you may see the problem with this earlier on before we actually get to the end of this check, but that's a good thing to keep an eye out for. So if we plug in negative 2 for x into our original equation, we'll have negative 2 plus 1 is equal to the square root of 3 times negative 2 plus 7. So we get negative 1 is equal to the square root of negative 6 plus 7. Now this is the point where you may smell something fishy going on here, because we've got a square root is equal to a negative number. And in the real numbers, that doesn't happen. And what we'll see here is that we get negative 1 And if we're trying to figure out if this equality is true, we're going to get negative 1 is equal to the square root of positive 1. This would imply that we're trying to say that negative 1 is equal to positive 1, which is definitely not true. So this is actually not going to be a solution, x equals negative 2. And again, this is a result of this step right here. Because we squared both sides of this original equation, we leave the door open for a possible false solution such as this. You know, we could see that if we went back down here and had squared both sides, you know, that would be true. But that's not the way that our original equation was set up. So what we conclude here is that so the only solution to this equation would be x is equal to positive 3. Okay, so always remember to check your solutions with these problems. Okay, let's try number 2. So here we're asked to solve, it looks like a relatively simple equation for x. X to the power of 3/2 is equal to 8. Okay, so when we've got x to the power of 3/2, and that's equal to 8, you know, if it was just x squared, we'd know to take the square root of both sides. If it was the square root of x, we'd know to square both sides. But we want to get rid of this exponent, 3/2. And what you probably learned in class is that if you would like to get rid of that rational exponent, the way we do it is we raise both sides of this equation to the reciprocal of that exponent. And we're going to see that in this case, let's go ahead and raise both sides. So raise both sides to the power of 2 divided by 3. Again, that's the reciprocal of the exponent that we're dealt with here. So we've got x to the 3/2 raised to the power of 2/3 is equal to 8 raised to the power of 2/3. Now what we're going to see over here is we've got, just to kind of see how this works, we'd have x to the 2/3 to the power of 2/3, excuse me, x to the 3/2 raised to the power of 2/3. When we have exponents raised to exponents, we multiply. So this would essentially be x to the power of 3/2 times 2/3. Which would just give us x, and this again is equal to 8 to the 2/3. We'll take care of the 8 later. With multiplication of fractions, we multiply across, so this would be 6/6. And again, this is not necessarily work that you would have to show, but we're just showing that by raising the left side to the power of 2/3, we get x to the power of 1, which is just our x, which is what we're trying to isolate here. Okay, so let's focus on this 8 to the power of 2/3 next to see if we can reduce this. And before we go running to our calculator, we should be able to handle this. Let's think about what raising something to the power of 2/3 means. We've actually got two ways to think about it, and either one will work here. So we've got two options. One way we could think about this is we've got the cube root of 8 quantity squared, or this 8 to the power of 2/3 could also mean the cube root of 8 squared. These are equivalent, and we're going to show that these actually come out to be the same value. I think the top one's probably the easier one to tackle in general. So the cube root of 8 is going to end up being 2, and if we square 2, we know that we get back 4. Let's see if we get the same thing down here. So 8 squared we know is 64, and if we take the cube root of 64, so we think, well, what times itself 3 times will give us 64? Well, 4 times 4 is 16 times 4 is going to be 64. So the cube root of 64 ends up being 4. So these work out in both cases. So we get that x is equal to positive 4. And that would be the solution to this one. So again, you don't necessarily need to take these two steps. This is more of just showing that you could view x to the 2/3 in two different ways, whichever one you feel is easier to work out by hand. Okay, so now we've got the last one. This one's a little bit tricky, but I think we are up to the challenge. So we've got 4 minus 2x to the power of 2/3 is equal to 4. Now, based on our experience from the last problem, we know how to handle this power of 2/3. We're going to raise both sides to the power of 3/2. So when we set this up, we're going to have 4 minus 2x. This is raised to the power of 2/3. But to solve for x and to get at x, we're going to raise this to the power of 3/2. And we're going to do the same thing to the right-hand side. So we're going to raise that to the power of 3/2. Now, I want for a second to think about what this means, what we've done here. We've raised both sides to the power of 3/2. Now, this is going to be an important implication on our solution here. So by using the exponent 3/2, so 3/2 to solve for this, essentially we just took the square root of both sides. Now think about that. You know, one way that we could visualize it is just, this is just an example. So for example, you know, if I had x equals 8, and I decided I'm going to raise both sides to the power of 3/2. So x to the 3/2, 8 to the 3/2. This 3/2 can be thought of as x cubed and then a square root. So remember, when you take the square root of both sides, when you actively apply the square root as a method of solving an equation, you have got to accommodate for a positive or a negative solution. As in this case, we would have to say, well, this is going to be equal to plus or minus the square root of 8 cubed. That's how we would have to set this up, because we're taking the square root of both sides. So that was just sort of not really applied to this problem, but the concept is. So by taking the exponent of 3/2, we just took the square root of both sides. So this implies that we need the plus or minus for our constant on the left, or excuse me, on the right here. So the result is we know that the left-hand side is just going to simplify down to 4 minus 2x. And we've got plus or minus the square root of 4 cubed. So that's exactly what we did over here in the blue with the 8, just as a principle. So now this means we've got 4 minus 2x is equal to plus or minus the square root, in 4 cubed we just talked about was 64. So 4 minus 2x is equal to plus or minus 8. So we're going to have two possible solutions that we're going to need to double check. So if we go ahead and we solve this, I'm going to just keep it as one equation and just keep track of that plus or minus until the end. So I'm going to subtract 4 from both sides. So I'm going to get 2x is equal to negative 4 plus or minus 8. Divide both sides by negative 2, and we get x is equal to minus 4 plus or minus 8 divided by negative 2. So let's check what these two values would be. So we've got minus 4 plus 8 divided by negative 2, and then we've got minus 4 minus 8 divided by negative 2. So that'll give us 4 over minus 2, which gives us negative 2. So that's one possible solution for x. And then we've got negative 12 divided by negative 2, which will just give us positive 6. And again, what we really should do in this case with these problems is to get in the habit of checking. So let's just go ahead and we'll do that. So if we check x equals negative 2, and we're going to run these back into our original equation here. That's where we're going to substitute. So negative 2, we're going to have 4 minus 2 times negative 2 raised to the power of 2 over 3 is equal to 4. and we want to know, is this in fact true? Well, let's see. So that's going to be 4. Negative 2 times negative 2 is plus 4. Raised to the power of 2/3. Is that in fact equal to 4? Well, that's going to give us 8 to the power of 2/3. And we want to check, is that equal to 4? All right, so we're going to have to do some simplification here. So again, 8 to the 2/3 is essentially the cube root of 8. That's the index of our root, is the denominator of our rational exponent. And the numerator of our rational exponent is the power that we apply to it, in this case squared. So we want to know, does that end up being 4? Well, this should sort of look familiar. So the cube root of 8 is 2, which we're then going to square. And what we get is 4 is in fact equal to 4. So we can check this one off, and we're going to accept that solution. So now we can double check our second one, which was x equals positive 6. So if we substitute that back in to our original equation, we've got 4 minus 2 times 6 raised to the power of 2/3. Is that equal to 4? Well, we've got 4 minus 12 raised to the power of 2/3 equal to 4. That's negative 8 raised to the power of 2/3. Is that equal to 4? All right, that negative might be worrying you, but let's think about what this rational exponent means. This is the cube root of minus 8 squared. And we can take the cube root of negative numbers, because we're asking ourselves, well, what number times itself 3 times will give us negative 8? Well, negative 2 times negative 2 times negative 2 will end up giving us negative 8. So the cube root of negative 8 is going to be negative 2, which we are then going to need to square, and we end up with 4 is in fact equal to 4. So in this case, it turns out that both solutions actually work, so that we can say that for this problem, so x could be equal to negative 2 or positive 6, and either of those solutions would work out just fine. Okay, so that does it for this worksheet, and I will see you all in the next video.